All right, so I kind of want to start out with another Padlet like we've been doing. I think these Padlets are um, they're meant to help engage you, maybe talk about something that isn't related to math. And so that's why I enjoy these questions a lot. Just because it's a different aspect of education, it's a different aspect besides just math, and I think it gets you thinking a little bit, maybe a little bit about yourself or your personality or characteristics, stuff like that. So the question is it okay to lie to protect yourself? And so um, the way I read it was, I think I try my best to live with integrity, and so if I have to lie to get out of a dangerous situation, which would be me protecting myself, then maybe I didn't have the best judgment leading up to that point. It's also important to define protect yourself. So if you're lying to protect your image, and when I say image, I mainly think of Instagram, social media, people that have influence. Maybe it's even in entertainment. But if you're trying to protect yourself or protect your image, then maybe you should not be so worried about what people think or the facade or the front that you have, but actually kind of more be concerned with the person that you are internally. So that's kind of the way that I read it. I think I would say 99% of the time it's not okay, but there are certain circumstances that it might be okay. So um, I think lying in general probably isn't the the most ethical thing to do, but I think that there are certain instances where it might be okay, but that instance is a fraction, a very, very small fraction of the time, and I think that it's usually best um, to just tell the truth. So I'm curious what you think. This question is vague and it's broad, and it's vague and broad for a reason, so that way you can have different ideas. You can come at it at different angles and bring your own twist to it. So, I want to spend the first 5 minutes of class. I've spent about 2 minutes and 30 seconds explaining and kind of giving my 2 cents about this. But we're going to do the same thing as we did last time. The Padlet will be in the description, or not the description. It'll be in our chat. So once it's in the chat, just click on it. The subject line again will be your first and last name, and then write your own post and submit it. Make sure you keep it school appropriate. I'll approve it and might even throw an emoji on it or something. So let me uh, help me with this Padlet. Try to participate in class and kind of give me your 2 cents on this idea, even though it's not math related. So we have about a little less than 2 minutes. So let's do this. Sorry, let's try to finish this Padlet out, and then we'll get started on our lesson here in a second. Have about 1 more minute, and then we'll move on. We're not going to spend as much time as we did yesterday. Uh, about 45 seconds, and then we'll move on to math. All right, so it's been about 5 minutes. We're gonna go ahead and move on. Um, if you would like, you can finish that later, or you can quickly wrap it up as we go on to, we're gonna go over 5.3 today. I will start off by saying I think I spent the majority of class time yesterday going over the lesson. So for today, I really want to spend maybe about 60 minutes, about as not as much time as I did yesterday, so that way class, um, I can give the class enough time to do the assignment. So I think the 5 question quizzes take about 10 minutes each. So if we have 20 minutes at the end of class to do those, whether you finished it in class the last time we met, or if you didn't, I want to give you time today to do both 5.2 quiz and 5.4 quiz, which is what I want us to do today. So just like yesterday, it'll follow the same format. We're going to go through everything that's already online in your online school portal. When we're starting out, just a lesson introduction, it says when you are deciding whether to see a movie or go to the park for the afternoon, many variables come into play: the weather, how much money you have to spend, your transportation, how many people are involved. In this lesson, you will work with variables just two at a time as they relate to each other in an equation. Uh, there's really nothing, or not nothing, but in the student guide, the one thing that I would have you at least pay attention to are the objectives, what we're trying to achieve out of this lesson, and that is we're trying to determine whether or not an ordered pair is a solution to a given equation, and we're trying to solve an equation in two variables in terms of one of the variables. So that is what we are trying to accomplish out of this lesson. For the first part, we have a couple of short video explanations.
To determine whether a value is a solution to an equation, you replace the variable with the given value and simplify. If you get a true statement, the value is a solution.
So for this problem, you had 2x minus 3 equals 9. And then you had if x equals 6, is that a solution to our equation? And all you do is plug in 6 for x. So 2 times 6, that's going to be 12. You subtract 3, you're going to get 9. And both the right and the left sides are equal to each other. 9 does, in fact, equal 9.
Some equations have two variables. A solution to this type of equation must include values for both variables that make the equation true. A solution to an equation in two variables, x and y, is any ordered pair, xy, that makes the equation true. Look at this example. Let's see if the ordered pair, 2, 4, is a solution to the equation x plus 3y equals 14. Replace x with 2 and replace y with 4. To simplify, multiply 3 by 4 to get 12. 2 plus 12 equals 14. Since we get the true statement 14 equals 14, the ordered pair, 2, 4, is a solution to the equation.
So same thing. This time it's an ordered pair. The question before was just an x. So now we talked about ordered pairs x and y. If if the ordered pair is 2 comma 4, that means that when you plug in a 2, your y should be 4. So if you plug in your 2 comma 4 into your equation, you should have a true statement because that is in fact a solution. So that's all that's saying, that when you plug in an ordered pair that is a solution to your equation, once you plug it in, you should get a true statement at the end.
Now, let's see if the ordered pair 8, 1 is a solution to the equation x plus 3y equals 14. Replace x with 8 and y with 1. When we simplify, we get the false statement 11 equals 14. 11 does not equal 14, so the ordered pair 8, 1 is not a solution to the equation.
Just like the video said, because at the end, your statement is not true. 11 does not equal 14. That is not a solution to your problem or to your equation.
Many ordered pairs satisfy an equation in two variables. Therefore, an equation in two variables has many solutions.
This part, it just says determine whether each ordered pair is a solution to the equation. We're determining if if our 2x plus y is equal to -10. We are trying to determine whether each ordered pair is a solution. So we're trying to determine if -2 comma -6. We're trying to determine if 4 comma -18. We're trying to determine if -1 comma 8, if those are possible solutions to our equation. So the way that we did that, just like you saw in the videos, is we're plugging all these in for x and we're plugging all these in for y. Each specific ordered pair to see if it's true or if it's false. So for the first one, you have 2. If I plug in -2 for x, then I have plus, and then -6 for y. And that's equal to -10. Then I simplify or reduce. 2 times -2 is -4. -4. Anytime I have plus a minus or plus a negative, that's just -6 equal to -10. -10 does in fact equal -10. So the first one is a solution. Remember, it's a solution if we get a true statement once we plug our ordered pair into our original equation. So this is our original equation, 2x plus y equals 10, -10. Plug the first ordered pair in, we got a true statement. I'm going to do the second, or the same thing for the second ordered pair. So you have 2x plus 2y, or not 2y, plus y, and that's equal to -10. We're plugging in 4 comma -18. So 2 times 4 minus 18 equal to 10, -10. 2 times 4 is going to be 8, positive 8, positive 8 minus 18. It's going to be -10. Let me make sure that's correct. Pulling that for y, 2 times 4. This should be -20. -26 equals -10. And that is not true. -26 does not equal -10. So this right here is not a solution to our equations. And then we have one more ordered pair. That last ordered pair is -1 comma 8. So if I have 2x, this is the same equation that we've been using. 2x plus y equals -10. And then we're trying to figure out, is -1 comma 8, is that a solution to our equation? So we have 2 times -1 plus 8 is equal to -10. -2 plus 8 equals -10. 2 plus 8 is positive 6. That does not equal negative 10. Let's see. Oh, I messed up right here. Whoops. For some reason, I was imagining another negative out there. There was not a negative. This should have been 8 minus 18. That should have been 10. I do not know why I did negative 26. So this, sorry about that, is actually a solution. I just wanted to double check that. For some reason, it didn't look right. So when we plug in our ordered pair for the first one, for that negative 2 comma negative 6, when I plug that in, I end up with negative 10 equals negative 10. When I plug in 4 and negative 18, I get the same thing, even though I don't know how to do basic math sometimes. So apologize for that. Negative 1 and negative 8, if I plug those in, I get 6 equals negative 10, and that is not a solution. So our we have 2 solutions, and then we have a 1 no solution.
Substituting -2 for x and -6 for y results in a true statement. Therefore, the ordered pair -2, -6 is a solution.
And then for second one,
Substituting 4 for x and -18 for y results in a true statement. Therefore, the ordered pair 4, -18 is a solution.
so again, going back to true statements and false statements. If it plug it in and at the end you get a true statement, then it's a solution. If not, then it's not a solution.
Substituting -1 for x and 8 for y results in a false statement. Therefore, the ordered pair -1, 8 is not a solution.
To find solutions to an equation in 2 variables, you must choose values for one of the variables and then solve for the corresponding y values. So, in the problems that we were given an ordered pair, we're given an x and a y. Sometimes you're just given an x. Sometimes it's asking you to solve for one of your variables, so to get y by itself or to get x by itself. So that's what this in particular is talking about.
To find solutions to an equation in 2 variables, you must choose values for one of the variables and then solve for the corresponding value of the other variable. Although it doesn't matter whether you choose values for x or y, we usually choose values for x and solve for corresponding values of y. So, how do we do this? For starters, use transformations to isolate one of the variables. Let's isolate y. In this example, we'll subtract 2x from both sides. We get y equals -1 minus 2x. With the transformed equation y equals -1 minus 2x, we can choose values for x and solve for y. A nice way to organize our work is to set up a table. The first column is for our x values. These are values that are either given to us or that we choose. Let's choose -2, 0, 1, and 3. Remember, you can choose any values for x. The second column is for the expression in terms of x that you will use to solve for y. In this example, we'll use the expression -1 minus 2x to find y. The third column is for the values of y that we find correspond with the x values. The fourth column is for the resulting ordered pair solutions, x, y.
So I want you to remember when we talked about how if there are different ways at looking at something in particular. So the last time we met in class, we were given a table, and we were able from that table to come up with a graph. And then now we're dealing with equations. So just like I said before, you can have equations, you can have tables, you can have graphs. And so when we got y by itself, now we can plug in our x. You can see what y is, and we get ordered pairs. And so um, that'll start to put together the pieces of a graph, put together the pieces of a table as we continue.
Now, let's find the corresponding y value for each x value. Substitute each value for x into the expression -1 minus 2x and simplify. When we replace x with -2, we get 3 for y. The ordered pair solution is -2, 3. When we replace x with 0, we get -1 for y. The ordered pair solution is 0, -1. When we replace x with 1, we get -3 for y. The ordered pair solution is 1, -3. When we replace x with 3, we get -7 for y. The ordered pair solution is 3, -7. Suppose we plotted points for the ordered pair solutions on the coordinate plane. What do you notice? The points lie in a straight line. Connect them with a line. The line is the graph of all of the solutions to the equation. The coordinates of any point that lies on this line is a solution to this equation.
I really like how this video puts it in perspective. I know I talked about tables, equations, graphs, but the way that this video explains it is kind of what I'm trying to get at when I say that.
Let's look at another example. The point with coordinates -4, 7 lies on the line. If we replace x with -4 and y with 7 in the original equation, we get the true statement -1 equals -1. The ordered pair, -4, 7, is a solution to the equation. Now, let's look at a point that does not lie on the line, such as 3, 4. If we replace x with 3 and y with 4 in the original equation, we get the false statement 10 equals -1. 10 does not equal -1. The ordered pair, 3, 4, is not a solution to the equation. Only points that lie along the line are solutions to the equation. Since there are an infinite number of points along a line, there are an infinite number of solutions to an equation in two variables. Any equation in two variables whose graph is a straight line is called a linear equation. Only points that lie along the line are solutions to the equation.
So we're going to have an example that shows us how to find corresponding y values for given values of x in an equation. So we're first asked to solve for y. So we have 6x plus 3y is equal to -12. 6x plus 3y. What we're trying to do is if we're trying to solve for y, all we're trying to do is get y by itself. So what I'm going to do is I'm going to subtract 6x from the left side, and then I'm going to subtract 6x from the right side. I do that so that way when I subtract 6x from itself, I get 0. I'm left with 3y on the left side. 6x, negative 6x minus 12. Even though I kind of have it written out to the side, if I have 6 is equal to 1 plus 5, even though I'm adding those two together, it doesn't really matter the order. 1 plus 5 is still the same thing as 5 plus 1. So when you're moving things algebraically and solving things that way and getting rid and multiplying by 1, sometimes order does matter, but when you're just having addition of two terms, one that has an x and one that is a whole number, it's okay if they're flipped. Is all I'm saying. It's okay if they're flipped. I'm trying to get y by itself. I'm going to divide both sides by 3. 3 divided by 3 is just 1, so that's why I get y by itself. Negative 6 divided by 3, that's going to be negative 2. And then negative 12 divided by 3 is going to be negative 4. And that should be my answer.
Begin by isolating the y term. Subtract 6x from both sides. 6x minus 6x is 0. You are left with 3y equals negative 12 minus 6x. Divide both sides by 3 to isolate y. Rewrite the quantity negative 12 minus 6x over 3 as negative 12 over 3 minus 6x over 3. Negative 12 divided by 3 is negative 4, and 6x divided by 3 is 2x. Y equals negative 4 minus 2x.
And just like I said, we got the same exact answer. It's just that our whole number and our variable with x were kind of switched. So that's okay that they were switched. We still got the same correct answer. These problems are just asking, determine whether, let me make sure I didn't skip anything. Expressions in two variables. I think I did skip some stuff. Okay, I was just making sure I didn't skip anything. Okay, so we're asked to determine whether these given ordered pairs are solutions to our equations. So if I have 2x minus 4y, 2x minus y, that's going to be equal to we have negative 3, negative 3. All we're going to do is plug this in for x. We're going to plug that in for y. We're trying to see whether or not this is going to be a true statement after we plug in our ordered pair. So if I have 2 times negative 3 minus 4 times negative 3, is that all equal to 6? 2 times negative 3 is going to be negative 6. Negative times a negative is going to be a positive. I'm left with negative 6 plus 12. That's going to be positive 6. That is, in fact, a true statement. That's a yes.
Great job. 6 equals 6 is...
And then our second question is going to be same equation, different ordered pair. So 5 comma negative 1. Same equation, so 2x minus 4y is equal to 6. We're trying to figure out if we plug in 5 comma -1, will we get a true statement? Plug this, we're going to plug this in for x. We're going to plug -1 in for y. 2 times 5 minus 4 times -1 equal to 6. This should be 10. A negative times a negative is going to be a positive. So this should be 14 equal to 6, and that is not a solution.
That's right.
Now we have a different equation. We have 3x plus 5y equals -12. 3x plus 5. 3x plus 5y equal to -12. We're trying to figure out if -4 comma 0, if that is a solution to our equation. So we're going to plug in -4 for x. You have 3 times -4 plus 5 times 0, and that's equal to 12. Let's make sure we are writing our equation correctly. 3 times -4 is going to be -12. Remember, anything times 0 is going to be 0. 12 plus 0 is just itself. That is, in fact, true. Is it a solution? Yes.
You got it.
Last one. Similar equation, different ordered pair. We have 1 comma -3. 1 comma -3. That same equation was 3x plus 5y equal to -12. So 3 times 1 plus 5 times -3, -12. 3 times 1 is 3. 5 times -3 is -15. 3 minus 15 is -12. -12. I hope that's correct.
Right. When you substitute the x and y values from the ordered pair into the equation, you get a true statement.
Okay, so this question is saying which equation is the result of solving 6x plus 2y equal to -8 for y. So it's saying if you got y by itself for this equation, which of the 3 answers would it be? So if we had in our question, it was 6x plus 2y is equal to -8. And all we're trying to do is solve for. So I'm going to subtract 6x from both sides. I get 2y equals -6x minus 8. Then I'm going to divide both sides by 2. 2 divided by 2 is going to be 1. -6 divided by 2 is going to be -3x. -8 divided by 2 is going to be -4. Let's see, -3x minus 4, -3x minus 4. Let's check it. And that is correct. If we go down, kind of shows the same work that we just did. This question says solve for y when x equals -2. So all we're doing is plugging in -2 for our x to see what our y would be. Plugging in. So if we have y is equal to -3x minus 4, all we're trying to do is plug in -2 for our x and see what y is. So y is going to be -3 times -2 minus 4 Remember, a negative times a negative is a positive. Negative 3 times negative 2 is 6. 6 minus 4 is 2. So our ordered pair is negative 2, comma 2. However, that's not what it asked. It's asking what our y is. Our y should just be 2. That's nice.
Nice work! Substitute -2.
Right, so finding solutions to see how to find solutions to an equation in two variables.
This is Mrs. Simmons. We will evaluate for y in the following problem. For the equation below, find the value of y when x equals 5 and when x equals negative 6. 4x minus 2y equals 16. Let's begin by solving this equation for y. To begin, we'll subtract 4x from both sides, which you see here in the second step. That gives us negative 2y equals 16 minus 4x. Then, to isolate y, we divide both sides by negative 2. When we simplify, we get y equals negative 8 plus 2x. Now we are ready to evaluate for y. Let's go ahead and evaluate first when x equals 5. This means we will substitute in 5 for x in the equation that we finished with in step 1. So here you will see us substituting 5. 2 times 5 is 10, and negative 8 plus 10 is 2. So if x equals 5, then y equals 2. Now we can evaluate for y when x equals negative 6. This time we will substitute negative 6 for x, which you see here in the second step. 2 times negative 6 is negative 12, and negative 8 plus negative 12 is negative 20. So if x equals negative 6, then y equals negative 20, and our problem is complete.
All right, so we are at our summary. Summary is just 2 pages. So it says determine whether 2, 4 and 8, 1 are solutions to our equation. Let's see. So our equation is x plus 3y is equal to 14. So it's just asking whether 2, 4, 2, 4 is that a solution to our equation. So plug in 2 for x plus 3 times 4. Is that equal to 14? 2 is just going to simplify to itself. 3 times 4 is going to be 12. That should be equal to 14. 2 plus 12 is 14. That is a solution. If you see right here, it has everything written down. You have your two points, 2, 4. And at the bottom, it does say, in fact, it is a solution. So we'll do 8, 0 real quick. 8, not 0, 8, 1. Same equation, x plus 3y equal to 14. Gonna plug in 8 for x plus 3 times 1. That's equal to 14. 3 times 1 is just itself. 8 plus 3 is going to be 11. We know that that is not a solution. Really quick. 8, 1, same steps we did. We know that 11 does not equal 14, and therefore not a solution to our equation. We're going to do the offline learning section. So we have our 5.03 quiz. I'm going to do this. We're going to do this together. So for number 1, it says which of the ordered pairs in the form x, y is a solution to the equation. So you have, let's see, go down. You have our equation is 3x plus 2y equals 6. 3x plus 2y, that equals 6. And then we're asked to find which ordered pair is a solution to all of those. So you had either no solutions within the given ordered pairs that were answer choices. So to figure this out, you would plug in 8 for x, -5 for y, plug in -2 for x, plug in 0 for y, and then plug in 4 for x, -3 for y. See which one is once you simplify everything, which one is a true statement at the end. So we know that the answer is 4, -3. Let's see, 4, 3. We want to make sure that we just don't know the answer, but know why it's the correct answer. Plug in 4 for x. That's 2, -3 equal to 6. 3 times 4 is 12. 2 times -3 is going to be -6. 12 times, or I'm sorry, 12 minus 6 is just 6 itself. That is, in fact, a solution. For question number 2 for the quiz, it says solve the equation for y. So if you're going to solve the equation for y, all you're going to do is get y by itself. We're given 2x plus 5y equals 5. All we're asked to do is to get y by itself. We're trying to solve for y. Subtract 2x from the left and from the right. I'm left with 5y equals -2x plus 5. Then I'm going to divide both sides by 5. 5 divided by 5 is just 1. -2 divided by 5, I'm going to leave that as a fraction. I know that 5 over itself is just 1. So this should be one of my answer choices, which it was, -2 over 5x plus 1, and that would be my answer for number 2. So the question says, which statement is true about the equation 3y minus 6x equals -3? If you notice, all of your questions says when x equals -4, and then it has a y solution. And then it says when x equals 2, you have all different y solutions. So if we plug in x for -4, plug in x for -4, and even though we know the answer, we still want to be able to understand why it's the correct answer. So that's our equation. Question is asking, what does y equal when x equals -4? So 3 times y minus 6 times -4. 4, 3. So I have 3y. Negative 6 times negative 4 is going to be positive 24. It's 3. If I'm trying to get y by itself, I'm going to subtract 24 from both sides. 3y equals negative 27. Again, getting y by itself, I'm going to divide both sides by 3. I have y equals negative 9. And the second answer choice is the only one that has negative 9 as an answer. So honestly, I don't even have to do the other side where x equals 2. Those are your answers for 5.03 for our quiz. We've spent about 46 minutes going over the lesson. I want you to do 4.04, right? No, not 4. 5.04. I want you to do that on your own. Before I leave you on your own, I quickly want to go over some of the things that it has. There's a quick wrap up, a quick review. I don't even think the wrap up says anything. Yes. So in the beginning, we talked about how there are different variables in life. Going to the movies, it talked about if you're going to the movies, if you're going to the park, if you're doing so on and so forth, there are different variables like the weather, how much money you have, how many people are coming along. And so even though these are just X's and Y's, there are still real world applications to these two-step or two variable equations. Quick wrap up, find it, prepare it, use it, save it. Quick review.
Let's talk about equations in two variables. Here's what we'll cover: solving an equation in two variables for one of the variables, finding a solution to an equation in two variables, and determining if an ordered pair is a solution to an equation. So what exactly is an equation in two variables? Well, it's an equation that has two unknown values, or variables. So for instance, the equation 5x minus 10y equals 25 has two variables, x and y. Likewise, the equation 7x equals 19y plus 17 also has two variables, x and y. Both of these are equations in two variables. But the variables don't have to be x and y. For instance, the equation 1 equals negative 9a plus 6b over 11 has two variables, a and b. Therefore, it's another equation in two variables. The equation 18m minus 4/5 equals 5n is also an equation in two variables because it has variables m and n. You can use transformations to solve an equation for one of the variables. Let's try a problem. Let's solve this equation, 4x plus 2y equals 8, for y. To isolate y, start by subtracting 4x from both sides of the equation. Then, divide both sides by 2. When you solve the equation 4x plus 2y equals 8 for the variable y, you get y equals 4 minus 2x. Once you have solved an equation in two variables for one of the variables, it's easy to find solutions to the equation. There are infinitely many pairs of x and y values that are solutions to this, or really any, equation in two variables. You're being asked to find just one of those ordered pairs. Begin by choosing a value for x, and in this case, I'll let x equal 1. So, substitute 1 for x in the equation, y equals 4 minus 2x, and then simplify. When you're done, you find that y equals 2. So when x equals 1, y equals 2. Use these values for x and y to form the ordered pair. One solution to the equation 4x plus 2y equals 8 is the ordered pair 1, 2. For our first solution to the equation, we let x equal 1, but we could have chosen any value for x. Let's find another one. This time, let's start by letting x equal negative 1. When we substitute negative 1 for x, we get the ordered pair negative 1, 6, which is also a solution to the original equation 4x plus 2y equals 8. We could find more solutions by choosing additional values for x, substituting each one into the equation, and simplifying to find each corresponding y value. For the equation 4x plus 2y equals 8, we've already found solutions 1, 2, and negative 1, 6. But are the ordered pairs 3, negative 2, and negative 2, 1 also solutions to the equation? You could determine if an ordered pair is a solution to any equation by substituting the values into the equation, simplifying, and then verifying that both sides of the equation are equal to each other. Let's try the first one here. Let's determine if 3, negative 2 is a solution to the equation 4x plus 2y equals 8. First, substitute 3 for x and negative 2 for y. Simplifying, we get 8 equals 8. The two sides of the equation are equal, so 3, negative 2 is in fact a solution to the equation 4x plus 2y equals 8. Now let's try the last one. Let's figure out if negative 2, 1 is also a solution to the equation 4x plus 2y equals 8. First, substitute negative 2 for x and 1 for y, and then simplify. Well, negative 6 does not equal 8. The two sides of the equation are not equal to each other. Therefore, the ordered pair negative 2, 1 is not a solution to the original equation 4x plus 2y equals 8. All right, let's do one more problem. Let's determine if the following ordered pairs in the form A, B are solutions to the equation negative 2a plus b equals 3. To determine if each ordered pair is a solution, substitute the corresponding values into the equation, simplify, and then verify that the left and right sides are equal to each other. Let's do the first one. Substitute the ordered pair 3, 9 into the equation and simplify. We end up with 3 equals 3. The two sides of the equation are equal to each other, so 3, 9 is a solution to the original equation, negative 2a plus b equals 3. Next, substitute the ordered pair negative 3, 3 into the equation and simplify. 9 does not equal 3. The two sides of the equation are not equal to each other, so negative 3, 3 is not a solution to the original equation. Isolate one of the two variables to solve an equation in two variables for one of the variables. Find a solution to an equation in two variables in the form of an ordered pair by choosing one value for one of the variables and solving for the other variable. And finally, you can determine if an ordered pair is a solution to an equation in two variables by substituting the values in the equation and verifying that both sides are equal to each other when simplified.
Okay, so a quick summary of what we've already learned while going over this lesson. I think there are a couple of practice questions for this practice quiz. I'm not going to go over all of them. Let's see. So solve the equation for y. So, okay, so it's asking to solve for y. You have negative 3y equals negative 5x plus 12. All you're trying to do is get y by itself. Divide the left side and the right side by negative 3. Negative 3 divided by itself is just 1. Negative divided by a negative is positive. We're going to leave it as a fraction, but a positive fraction. 12 divided by negative 3 is going to be negative 4. And that should be my answer. 5 over 3x minus 4. Correct. Second question says solve the equation for x. So we are used to solving for y. In the beginning of the lesson, one of the videos said that you can interchangeably solve for x or you can solve for y. So don't forget that the same steps to get x by itself are applied or the same way that we would get y by itself. So you have 3x, it's equal to 4y plus 15. I'm going to divide both sides by 3. 3 divided by 3 is just x. I'm left with 4 over 3y. 15 divided by 3 is 5. So 4 over 3y plus 5 should be correct. For this one, it says, which point on the graph lies on an ordered pair that is a solution to the equation? What you have to do is you have to come up with, tell me what the ordered pairs are for P, for Q, for R, for S, and then you plug those ordered pairs into our equation to see which one would be true. So for P, the ordered pair is -4, 4. For Q, the ordered pair is 4, 2. For R, ordered pair is 2, -3. And then for S, it's going to be -3, -2. The way that we would get our answers is that you're going to plug in all of these ordered pairs into your equation to see which one would be true. And then if there's only one correct answer, then only one should be true, and then 3 should be false. Let's see. Our correct answer should be Q. When we plug in Q, we should get 2 times 4 minus 2 times 2 equal to 4. 2 times 4 is going to be 8. 2 times 2 is going to be 4. 8 minus 4 is +4. Last question, and then I will leave you on your own. Which ordered pair is in the form A, B? I'm sorry, which ordered pair in the form A, B is a solution of the equation 4a minus 5b equal to 24. Even though it's A's and B's, not Y's and X's, it's the exact same thing. It's saying that A, B, and you have 4 minus 5b equal to 24. This is the same thing as saying x, y, and 4x minus 5y equals 24. When you have a and b and x and y, when you have a variable, it's just an unknown number. So you don't know what that number is. So the same thing that we've been doing is what we how we're going to solve this problem. So in all of the answer choices, you have -6, 0. You have 11, 4. You have 4, 11, and you have 0, 6. Same thing that we've been doing. You're going to plug in -6 for x, 0 for y, or you can look at it because we know that our ordered pairs are written in A, B. You can plug in -6 for A and 0 for B. Let's see, so we have remember, only one of these answer choices is going to be correct. 4, -6 minus 5 times 0. I do not know if this is the correct or wrong answer. This is going to be -24. Anything times 0 is going to be 0. This is going to be 24. Be careful. This is almost the correct answer. One side is negative, one side is positive. That's how you would do it. You'd have to go through and plug in every single one of those ordered pairs to figure out which one was true, which one was false. Gonna leave it there. And then the next step would be to finish your 5.04 quiz. So I'm going to leave the rest of class time for you to do that. If you did not finish your 5.02 quiz, I'd advise you to do that as well. They are all due at the end Friday. What else? We're kind of done for the day as far as lessons go. After you finish your assignments, you're more than welcome to have the rest of class time to yourself. I will be available if you need any help with anything. Just let me know. If you have questions, I'll be here for you. Other than that, we are kind of done for the day. So just let me know if you need any help. I'll be here.